Bismillahirrahmanirrahim. Welcome to Excellence Academia. Please subscribe, like, comment, and share our videos. Thank you so much. Bismillahirrahmanirrahim. Welcome to Excellence Academia. By the name of Almighty Allah, who is the most beneficent and the most merciful. Dear students, respected teachers and friends, Assalamu alaikum. Students, this is the lecture series of FSC Part 2 Mathematics, and we will discuss 7.4 in our today's lecture. 7.4 part number 2. It means question number 5 to onwards. Today we will discuss question number 5 to 9. So, FSC to exercise number 7.4. First of all, question number 7. Question number 5. Question number 5 is, if we have 3 vectors and we find or we check the perpendicularity or parallelity of the vectors. It means, first part, u vector is equal to 5i minus j plus k. V vector is equal to j minus 5k. And w vector is equal to minus 15i plus 3j and minus 3k. So we have to check whether these vectors are perpendicular to each other or parallel to each other. So for perpendicular vectors we find its dot product. If dot product is 0, then the vectors are perpendicular. If vectors are not perpendicular, then we find its cross product. If cross product is 0, then the vectors are parallel. So first of all, u dot v for perpendicular vectors. U dot v is equal to 5i minus j plus k dot 0i plus j and minus 5k. So 500 minus 1 minus 5. This is equal to minus 6, which is not equal to 0. It means u is not perpendicular to v. Now, similarly we check u cross v. I, j, k. 5 minus 1 and 1, 0, 1 and minus 5. Now check its cross product. So I minus 1, 1, 1 minus 5, minus j, 5, 1, 0 and minus 5, and finally k, 5 minus 1, 0 and 1. So it becomes I 5 minus 1 minus j minus 25 minus 0 and plus k 5 minus plus 0. So this is equal to 4i plus 25j and plus 5k, which is not equal to 0. It means u is not parallel to v. So it means u and v are neither parallel and not perpendicular. Similarly, you can find u dot w. So now check u dot w. First of all, u dot w for perpendicular. U is equal to 5I minus j plus k dot w minus 15I plus 3j minus 3k minus 75 minus 3 minus 3 minus 81, which is not equal to 0. It means u is not perpendicular to w. Now u cross w, I, j, k. So u value is 5 minus 1 1 minus 15 3 and minus 3. So I 3 minus 3 minus j minus 15 plus 15 and finally k minus 15 plus 15. It becomes 0I, 0j and 0k, which is equal to 0, null vector. This implies that u is parallel to w. This is our required result. Similarly, you can check the vw. This is our question number 5. Now question number 6. Question number 6 and 7 are proofs, but very easy proofs. Question number 6 is prove that A cross B plus C plus B cross C plus A plus A cross C cross A plus B, which is equal to 0. We have to show that left side is equal to 0. So for this, solving the left side, taking the cross products. So this becomes A cross B plus A cross C. Similarly, B cross C plus B cross A, and similarly C cross A plus C cross B. Now we know that in cross product A cross B is equal to minus times of B cross A, because cross product is a vector quantity. That's why if we changing the direction, then change the sign. Or this is equal to B cross A is equal to minus time of A cross B. Using this condition, we get A cross B plus A cross C plus B cross C. So B cross A equal to minus A cross B. Similarly, minus A cross C, and similarly minus B cross C. So all values have opposite sign. This will cut with this with this, and this with this. So cancel all values. We have 0. So this is your required answer. Students, you can see this proof is very easy. Just using the condition of cross products, we find the values this equal to 0. So now one more proof. Question number 7. Question number 7 is important. So statement is if A plus B plus C is equal to 0, then prove that A cross B is equal to B cross C is equal to C cross A. We have to show that if this condition is given, then prove that this condition. So start. If a plus b plus c is equal to 0. So first of all, plus c minus c. Now taking cross product with c. So c cross a plus b is equal to c cross c minus c. So this is equal to c cross a plus c cross b. So cross product of similar vector is 0. So c cross a is equal to minus time of c cross b. So this will be, if we reverse the vector, the sign is changed, plus b cross c. Equation number 1. Similarly, again, a plus b plus c is equal to 0. Now, b plus c is equal to minus a. Now taking cross product with minus with a vector. A cross b plus c is equal to a cross minus a. So this will be a cross b plus a cross c. Cross product of singular vector is 0. So this is equal to a cross b is equal to minus a cross c. So this will be a cross b is equal to c cross a plus. So here you can see that one side is same, so we can compare these two equations. Comparing 1 and 2, it means a cross b is equal to b cross c. A cross b is equal to b cross c. So this implies that a cross b is equal to b cross c is equal to c cross a. This is your required answer. So one more question. Question number 8. Sine proof. Question number 8 is, prove that sine alpha minus beta. Question number 8 is, prove that sine of alpha minus beta, sine alpha cos beta, and minus cos alpha sine beta. So you can solve it similarly as this angle is alpha, so cos alpha sin alpha, and this angle is beta, cos beta sin beta, and this will be alpha minus beta. So here we have origin. So first of all, OA vector is equal to cos alpha I plus sin alpha j. So magnitude of this vector will be 1. Similarly, OB vector cos beta I plus sin beta j. So OB magnitude is equal to 1. Cos k plus sin k is equal to 1. So now in sin theta we take cross product on this direction. So first OB vector, then A vector. So OB cross OA with by definition. So OB magnitude, OA magnitude, sine of alpha minus beta. So equal to 1 into 1 sine of alpha minus beta. This is our equation number 1. Now finding the cross product. So OB cross OA is equal to IJK cos beta sin beta and 0, where K unit vector. A cross B definition is AB sin theta and unit vector. In this we have xy plane, so perpendicular with the K unit vector. So similarly this is equal to cos alpha sin alpha 0. So I 0 minus 0 minus j 0 minus 0 and finally K sin alpha cos beta minus cos alpha sin beta. So this will be OB cross OA is equal to sin alpha cos beta minus cos alpha sin beta, K unit vector. So putting this value in equation 1, by putting the value in equation 1, so we get sin alpha cos beta minus cos alpha sin beta. K position vector is equal to sin of alpha minus beta into K vector. So K vector, position vector. So comparing coefficient of K, this implies we have sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. This is your required answer. And there is a mistake in the book. In book, here is the plus sign. You can correct the sign because sin alpha minus beta have the minus sign on right side. Okay, students, last question. If A cross B is 0 and A dot B is 0, what conclusion? So you know that A cross B is 0, then vectors are parallel vectors, and A dot B is equal to 0 is the vector or perpendicular vector. So last question is the oral question. This is the last main question of exercise number 7.4. इंशाल्लाह नेक्स्ट एक्सरसाइज में आप 7.4 को डिस्कस करेंगे, ट्रिपल प्रोडक्ट को. तब तक के लिए हमारा यूट्यूब चैनल सब्सक्राइब करें और इसे दोस्तों के साथ भी शेयर करें. थैंक यू सो मच.